In this video, we're going to continue looking at exponential functions, and this time we're going to look at graph transformations of exponential functions. Now, we've previously met graph transformations. We know that given any graph f of x, we can reflect, move or scale it, and each transformation that takes place influences the points on the graph. So in order to keep track of those influences, it's really good to use a table of points. So we met lots of rules before in the functions and graphs topic for transforming graphs, and the same rules apply for transforming exponential graphs. So hopefully you'll remember this table from before, and you can see that our first 5 transformations here all have an effect on the y-ordinate, and our last 5 transformations here all have an effect on the x-ordinate. So hopefully you have remembered those. If not, I would pause the video just now and study this table a bit further, just to remind yourself of what's going on. So let's have a look at an example on transformations of exponential functions. So we are asked to sketch the graph of y equals 1 plus 2 to the power x. So if we think firstly about the exponential function that's actually happening here, the basic exponential function of the form a to the power x is this part, the 2 to the power x. So if we look at y equals 2 to the power x, we know 2 points on that graph. We know the point 0, 1 and 1, 2. So let's plot that firstly. Now, we are asked to sketch the graph, however, of y equals 1 plus 2 to the power x. So let's look at what happens to these points. So we are adding 1 onto all the y-ordinates. So instead of 0, 1, we're going to have 0, 2. Instead of 1, 2, we're going to have 1, 3. And then what we can do is plot those points, 0, 2 and 1, 3, and sketch the graph of 1 plus 2 to the power x. So just now would be a good time to pause the video and copy this example down before coming back for example 2. Okay, welcome back folks. So example 2 asks us to sketch the graph of y equals 3 to the power 2x. Now we've been used to seeing ones that would be like 3 to the power just x, singular, 1x, but this time it's 3 to the power 2x. So to start with, I'm going to make you revisit one of the laws of indices. If you have x to the power a and you raise that to the power b, then that's the same as x to the power a multiplied by b. So if we have a look at what we have here, 3 to the power 2x, and remember we're dealing with exponential functions, so we want to try and express that in terms of 3 to the power x. So in actual fact we can write that as 3 to the x, there's our exponential function, and we are then squaring it. So it looks as though we are going to be squaring all of the y-ordinates of the points which will occur on the original graph of y equals 3 to the x. So you always want it to be related back to something you know of, something that you're more familiar with, like y equals 3 to the x, where we would have the points 0, 1 and 1, 3. Obviously we can go ahead and plot that graph, but we want y equals 3 to the power x all squared, i.e. 3 to the power 2x here. So we want to square all of our y-ordinates, and we can see that 0, 1 will still be 0, 1, and the point 1, 3 will become 1, 9, because we've squared the 3 here to become a 9. And if we then go and plot these points, obviously 0, 1 didn't change, we've got 1, 9, and we can then sketch that graph. And that's the graph of y equals 3 to the power 2x. So just now would be a good time to pause the video before the screen goes blank and copy this one down in your notes before trying the assigned exercise for today.